Okay, so I wanted to talk to you about homework. Okay, homework is something you're gonna get in this class. I've got a homework assignment for every chapter in the class, a number of problems. You need to do your homework. I will not be grading it or I will neither collect it nor grade it. Okay, so you are responsible for doing your homework, and I really want you to do it. Okay, this is very, very important. That you do this, and I would say with a great deal of confidence that if you don't do your homework, you're going to really struggle in this class. Okay, so what I want to do is go over some general issues about some general tips about solving homework. But let me do a little demonstration for you first. This is you and your homework, and me and you and problems. Okay, I'm going to solve problems on the board, homework problems on the board. You're going to watch me solve them, and you're going to decide that it's pretty simple to do in most cases. And then you're going to go off and get it on an exam, and you're going to discover that you don't really understand exactly what I did. And you can't unless you do the problems yourself. So let me show you what my analogy of homework is. I have two wine corks here, okay? And it's all I'm going to do. I'm going to do a very simple trick. Some of you may have seen this before. It's not really a trick. It's just I'm going to do this. I'm going to take both corks and I'm going to put them in between my thumb and my index finger. Okay. And what I'm going to do is I'm just going to reach around here and I'm going to grab the corks with either hand and separate them. So I reach around like such and I take them apart like that. Okay. Very simple. Okay. I'll do that. Let me do this again. I want to just show it to you and I'll do it real slow. Okay. So again, this is just the where I've got my corks, okay, and I reach around and I take a hold of them and I separate them like that, okay. Now I can do this for you uh, fast, slow, far away, close up, many times as I want. And when I hand you these corks, I have a high level of confidence, very high level of confidence. Unless you've seen this before and you practiced it, you will not be able to do it the first time. You'll have to work on it to be able to do what I did. And that is exactly what happens with homework. You have to do problems in order to get proficient at them and understand how to use them. Okay, so here's what we're going to do is I want to talk, first of all, let's take a moment and talk about problem solving in the physics class. First of all, these problems in the back of your book, in the back of each chapter, are word problems. That means they've already done some of the work for you. If you're actually a practicing physicist and you want to look at some natural phenomena, you have to somehow turn it into words. Okay, so they've already done that for you. So the problem is sort of partially solved when you start it. Okay, now when we do this physics problems, here's what we're doing. We are basically starting out by doing physics, then we will always have to do some math. And then when we're done doing the math, we're going to do physics again. This is a somewhat simplistic a notion of solving these problems, but basically this is the way it works. We do some physics at the beginning. We read the word problem and we convert it into mathematical equations. And that's doing physics. That's applying natural phenomena to mathematical equations that we can quantitatively analyze. Okay? Once we have the proper equations down, converted, then we do some math. We solve the equations. Preferably, we're going to do this symbolically. I'm going to encourage you all to do it symbolically. Don't plug numbers in right at the beginning. Let's work our way all the way through using X's and Y's and Z's and P's and Q's and stuff so that we have a general formula at the end. Now, once we've solved the problem, then we do some more physics. We look at an answer and we ask, does it make sense? We examine the answer to see if it tells us any more about the phenomena that we're looking at. We want to understand what the answer is telling us. So these are the processes that we do it. And in some cases, we may do physics and then math, and then have to go back and do physics again and then math and stuff. But there's this interspersed thing. And this is a physics class. It's not a math class. You have to know your math. But I want to teach you physics. Okay? So here's what I'm expecting when you are doing problems. Okay? In all the problems, what you're going to do, first of all, I want to reiterate that the word problems are already sort of halfway there because they have written down in words what some nature is telling them. Okay, so what you're going to do is very important to read the problem, and you always should read it twice and try to visualize what it's saying. Okay, every problem represents something physical in nature. Be sure you understand what the problem is asking. It's going to say, give me an answer. Know what it's asking for, okay? And also, when you read it, look for quantitative things inside of the word. So if, for example, I read a word that says a truck is undergoing a uniform acceleration, that I would read the word uniform as a constant acceleration. It's uniformly accelerating. So you have to interpret what the words in the problem mean. Okay, so read it twice. You got to do that. You got to think about the problem and think about the assumptions that are being made. Okay, explicit and implicit assumptions. Okay, sometimes they can't say every word that needs to be in there, and sometimes you're going to have to make some assumptions. So understand the assumptions that you're making in these problems. Okay. Draw a picture. This is very important. I want you to always try to draw a picture, and it can be a very simple picture. I do my pictures have stick figures in them, and they have very simple types of drawings of cars and stuff like that. Don't make it elaborate, but draw a picture. That picture's it's worth 1,000 words. That's really true here. It will really help you sort out what the problem is asking if you can draw a picture of it. And finally, do practice symbolic manipulation. Don't plug numbers in at the beginning. There's a number of reasons for this, but one of the reasons is because you can make mistakes early on by plugging numbers in. When we're done and we have a symbolic answer, then we can do a lot of what ifs. We can say, what if the angle were this big? Or what would happen if something like that? You're now able to plug in numbers and you can see what happens, and you'll get much more information out of the answer if you have it in symbolic notation. Okay, and check your work at every step. Think about what you've done at each time. I want you to do that. Don't rush through. And finally, when you're done, you verify your solution correctly. Make sure that the solution is what the question was asking for. You have to have that correlation between the two. Okay, and take a look at your answer and see if it makes sense. Okay. So now, finally, so that's what I want to say about the homework. We're going to do that every time we do homework, and when I do problems on the board, I'll try to do these steps for you and show you how I apply them. And now, finally, I'm going to close this video by hypnotizing you. Okay? And so I am going to count to 10 and snap my fingers. You will wake up and you will do your physics homework. You will do your physics homework. Please do your physics homework. Okay. I'll talk to you later.